Our last and final speaker, Dr., well, we'll say Andrei, Dr. Illarionov, something like that. We'll let him pronounce it right, is a senior fellow at the Cato Institute Center for Global Liberty and Prosperity. From 2000 to December 2005, he was the chief economic advisor to the then president of Russia, Vladimir Putin. He is one of Russia's most forceful and articulate advocates of an open society and democratic capitalism, and has been a longtime friend of the Cato Institute. And what he's presenting today is from the fact he's the president of the Institute of Economic Analysis in Moscow, Russia. So he's going to present a study that was done at the Institute of Economic Analysis, not from the Cato Institute in the U.S. He's a senior fellow with the Cato Institute. So this is from his studies in Moscow, and we thank you and welcome our next speaker.
Okay. Good morning. This is a real pleasure to be here and to have a chance to present here the results of the study that have been done at the Institute of Economic Analysis. And here, just thank you for this attempt to clarify. This is a confusing announcement because the table here is called Andrei Illarionov, this is my last name, Cato Institute, Russia. Cato Institute is a very influential think tank, but it did not reach Russia yet. And there is an Institute of Economic Analysis, which I have an honor to be a president. And this report has been prepared mainly by my co-author, Natalia Pivovarova. Her name is here. There is also a website of the Institute. And I'd like to present the third report in the row of reports devoted to the analysis of the Russian segment in the HADCRUTI database. Now, time is for methodology. Okay, what should I put here? Okay, let's hear. Here two previous reports, as you can see here. The one has been published on December 15th, year 2009, 5 months ago. It was called How Warming is Made, the Case of Russia, and it had some discussions in mass media. Probably some of you could remember it was about how data for Russia has been cherry-picked and selected and to produce desirable results. A couple of weeks after that, we have prepared the analysis of the Russian segment in the HADCRUTI database, data and sample quality, showing how poor quality of data, how sampling had been used, once again, to produce desirable results. But now we're moving to this third area, which is called methodology. Let's try to start with the document that now is also spreading around the world, not only third assessment report or fourth assessment report. Now we have a country's assessment report. And a couple of years ago, Russian, some kind of part of this international team has produced this called Russian part of the ICCC team has produced a report which is called Russia's Assessment Report. It is quotation from this report, and that is actually have been repeated in a couple of pages. Over the last 100 years, the average global warming was 0.74 degrees Celsius, number which is very well known to everybody, while in Russia, temperature on average rose 1.29 degrees Celsius, which is, okay, the result of these calculations. Both numbers are pretty consistent with each other. They are calculated by members of the same international group of climate scientists. They apply the same methodology to the same data sets from the same databases. So this basic methodology for calculation of the global temperature is described in this also very well-known article written mostly under the leadership of Professor Phil Jones in Review of Geophysics in 1999. There is a website. And the part of the HADCRUTI dealing with the land temperature is a database of the Climate Research Unit of the University of East Anglia. CIU. And the principal author of this database, as you can look into this, it is partially available right now, is also Professor Phil Jones. So this result, 0.74 degrees Celsius increase in the global temperature, is the result of application of the Professor Phil Jones methodology to the global data from the HADCRUTI database. And the 1.29 degrees Celsius increase in the Russian temperature is the result of application of the Professor Jones methodology to the Russian segment in the full HADCRUTI database. Once again, they're very consistent. It's a part of the same general database. So the question is, should we trust these numbers or shall we check them first? We have in Russian such a proverb, trust but check first. Okay, so we tried to follow this recommendation from our predecessors. So as you know, last December 8th, year 2009, part of the HADCRUTI global temperature database was released and put on the Hadley Met Office website. And here is some part of description that has been added to this database. Look at this. They just underlining that the subset of stations that had been put on web is evenly distributed across the globe and provides a fair representation of changes in mean temperature on a global scale over land, and so on. And they even promised that maybe they could put at some point even data for 5,000 stations in total. So we looked not all data that they have put on the website, but we studied we are very much interested in the results for Russia. And we found that the Russian segment of this HADCRUTI database, released on December 8th, has temperature time series for 121 Russian meteorological stations. We also found that at least for more than a year than this data available, since December year 2008, the Russian Institute of Hydrometeorological Information, that has a special name, World Data Center, WDC, maintains in public domain the database of temperature time series from 476 Russian weather stations selected for international scientific exchange. So that is why the first, and just here the website, and everybody can go there and download. So the first actually question would arise, why the HADCRUTI database has chosen as selected only 121 stations, not 476 that are available, publicly available, and you don't need to get any permission from any authorities, because Russian authorities already gave not only permission but even data itself, not only for Hadley Center, not only for CIU, but for anyone, including everybody sitting here or who would like to just play with data. Okay, so that is why you would have at least 4 times more data. And since Russia probably not the smallest countries in the world, so the more data would be not worse for the quality of the results. So, and also presumably the data from these two databases and the results of their processing should coincide. And as we looked into it, we found that in some ways they do indeed, but in a very interesting way. Just look at this. Just please guess how many temperature time series from the individual weather stations you would need to calculate an average temperature representative for the whole Russian territory. Just a note here, Russian territory, slightly more than 17 million square kilometers, which is 11.5% of the world land mass. And just question, it's 476 stations, like it's from World Data Center, 121 stations from HADCRUTI, or here just some numbers here, 37 stations, 12 stations, or just 4 stations. You're thinking, right? Guessing. Just you have 5 choices, at least. You can more. Okay, let's check locations of those stations. This is 476 stations on this grid, as you can see. Here's the latitude, longitude, and this is more or less Russian territory, as you can imagine, right? This is 121 stations, And you can see the substantial portion of the Russian territory are not covered by these 121 stations. As we found that 40% of the Russian territory and slightly more than 5% of the global land mass are not covered by the HADCRUTI database. And this is a location of 37 stations, and this is of 12 stations, and this is of 4 stations. Just you would remember there's some kind of approximate location of these stations. And now let's try to perform a little trick. They do perform some tricks, right? We remember some tricks, and we would do some tricks as well. Here you see graph. You will see in a moment. This temperature anomalies for the Russian territory, for all Russian territory, for a period from 1850 until year 2008, taking 1961 to 99 base period, as almost everybody is taking, with 11-year moving average, just very standard procedure. And just let's look how they look like, these anomalies calculated based on these different samples of stations. First, 476 stations. This is for Russian territory, okay? Here's 121 stations. Here, 37 stations. Here, 12 stations. Here, 4 stations. Impressive. We played with these tricks many, many months. And we do receive the same picture. Actually, we just make some kind of mathematical computations. We would find the results essentially the same. The slight changes with just flying between 1.25 degrees Celsius to 1.35 degrees Celsius. Just essentially, it is just in the magnitude of error for 100 years. So that is why it doesn't matter whether we work with 476 stations data, or 121, or 12, or 4. So what does it mean? It means that by applying the Professor Jones methodology to the Russian segment of the HADCRUTI database, or to the Russia's World Data Center Temperature database, we could come to the following conclusion. The average temperature anomalies based on 476 stations essentially do not differ from the calculations based on data from 121 stations, or 37 stations, or 12 stations, or 4 stations. The question immediately arises, what are those stations, 121, 37, 12, and 40, especially these 4 miraculous stations that are able to offset all the rest once? The answer is very clear. They are the longest existing weather stations established before 1859, and naturally that time in urban centers. Even that time it was the largest urban centers, and in most cases they are the same. So this is the 4 miraculous stations on the Russian territory, and you can see them. Okay, well, what should I use here? All right, here are the names: Arkhangelsk, Yenisei, St. Petersburg, known to some people, Astrakhan. Here these are index numbers according to World Meteorological Organization. This is the establishment, as you can see, St. Petersburg from 1743. Population in the year 2008 from 356,000. Only Yeniseisk has 19,000 people. St. Petersburg, 4.5 million people. And Astrakhan, 500,000 people. Number of relocations of station, because they could be relocated, from 2 of them have been relocated 1 time, and 1 of them even 15 times. Just you can have actually think about the quality of data when station is being relocated, and so on. So, what does it mean? It means that for calculating the Russian and then, therefore, global temperature averages, first, the temperature time series collected from more than 99% Russian weather stations are excessive. The measurements made at these weather stations established after 1859 are unnecessary. And the quality of data and the data itself at all those stations doesn't matter at all. What matters? The methodology. The methodology actually offered by Professor Jones. What's special in this methodology? Just let me demonstrate some peculiarities of this methodology, comparing results for temperature changes for this particular period, 1921-1945, this 25 years period, to 1961-1990, 30 years period, depending on the population size of the territories near these weather stations. We can have such a wonderful picture. As you can see, here these weather stations where there is no permanent population, or almost none. For this period of time, temperature changes was negative, minus 0.36 degrees Celsius. In the locations with population less than 10,000 people, there was also negative temperature change, but was slightly smaller than at the stations with no population. In the weather stations with population between 10 to 50,000 people, there was a temperature change, but positive, but relatively modest, 0.17 degrees Celsius. At the weather stations with population between 50 and 300,000 people, was more pronounced warming, 0.23 degrees Celsius. And the largest warming was at the weather stations with population more than 300,000. What could we say about that? It was a successfully measured urban heat effect, depending on the population size. We looked for other periods between 1921, 1945 to 1991, year 2006. So it's already some kind of 70 years period. The same approach. Here, these weather stations, where there is no population, there is a warming by 0.31 degrees Celsius. It is permanently rising with the rise of populations at the weather stations, and it is the largest at the weather station with populations more than 50,000 people. For another period, for 100 years period, for the century, the same approach. The smallest increase in temperature at the weather stations with population less than 7,000 people, the largest at the weather station with more than 250,000 people. And finally, the temperature changes over the last century at the 10 stations with less than 1,000 people and with more than 500,000, 530,000. This is 0.87 degrees Celsius, and here 1.35 degrees Celsius. This is a difference of roughly 0.5 degrees Celsius, which could give you a flavor of the size of urban heat effect, because all stations, regardless where they're located, whether they're in the European part or in Siberia, in the north and south, whatever, the same story here. So, let me remind you one of the first slides that I show you, this quotation from this Russia assessment report, that the temperature in Russia on average was 1.29 degrees Celsius. And the previous, here, 1.35 degrees Celsius for urban centers with population more than 500,000. So what does it mean? it means that the 1.29 degrees Celsius increase in temperature is a real one, but it is a successfully calculated increase in the temperature at the stations located in the Russian oldest and, as a rule, largest urban centers. So it's an increase in urban temperature, not in all temperature. So, and if, as we know, that this calculation of Russian temperature based on the Professor Phil Jones methodology that actually apply to all the data set. So the question is, what does 0.7 degrees Celsius increase in the global temperature stand for? Thank you very much for your attention.